I cannot teach a computer, artificial intelligence, how to do something if I don't know how to do it. That would be kind of ridiculous.
This is DevOps Paradox, episode number 205. Thoughts on digital twins and custom silicon. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darin and Viktor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darin reading this text and feeling embarrassed that Viktor made me do it. Here are your hosts, Darin Pope and Viktor Farsic. I saw a blog post recently. Now, at the time you're listening to this, it's not so recently. This episode's releasing on April 5th, 2023. But I was going back through some of the AWS reInvent stuff, and I happened to see a blog post from Werner Vogels. I almost messed up. Okay, help me explain something because you're from that side of the world, Viktor. Werner's name is spelled with a W, right? His first name is what I would say Werner Vogels is how I would say it, but it's Werner Vogels.
Okay.
So why is the W and the V pronounced the same way? Or am I just being a stupid American and just don't understand the nuances of those letters?
I don't know. I tend to live... I was born in a country and now live in a different country. And in both countries, the logic is very simple and the only logic that makes sense. And that is that each letter is a sound. English is messed up. My daughter initially was saying hose. No, hose.
Hmm?
That was house. Because it doesn't make any sense to pronounce it house.
Okay. Anyway, that's not what we're doing this episode about, but it's interesting. Anyway, I saw this blog post that Werner did called Tech Predictions for 2023 and Beyond. Now, the link to that blog post will be down in the show notes, so you can review it at your leisure. I want to call off all 5 of them real quick, but we're going to dig into 2 of them. Number 1 is cloud technologies will redefine sports as we know them. Viktor, I know you're into sports.
B.
Moving on.
Or you're talking about some other sports?
Esports. Yeah, you're on esports.
Yes.
No, it's other. This was physical sports.
Don't
Anyway.
be disrespectful.
And I agree with that.
Disrespect the sports only because you don't like them. Now, esports are not a thing. They are.
They're a very big thing. I agree. Now, I just don't understand. I don't understand them. That doesn't mean anything. Okay, anyway. Number 2 is simulated worlds will reinvent the way we experiment. We're going to come back to that one. Prediction 3 is a surge of innovation in smart energy. Okay, sure, why not? Solar. Okay, if we don't use solar, what do we use? We use coal, we use wood, we use nuclear, we use wind. Is there anything else?
Nuclear.
I said nuclear, but do we just wait for our alien overlords to show up with a new form of geothermal is another one. I forgot. Anyway, so we're not going to speak a lot on that one. Okay. Prediction number 4, the upcoming supply chain transformation. Now, in this context, we're talking about physical supply chain. Drones, autonomous fleets for shipping packages, all this kind of stuff. But in our world, supply chain from a software perspective is going to be, I think, one of the hot things for this year.
Oh, yeah.
But again, we talk about that a lot. So it's interesting to see them talk about it from a physical perspective. Remember, he's the CTO of Amazon, by the way, if you didn't know who he was, who Werner was. Prediction number 5. And this is one we're going to also talk about. Prediction number 5 was custom silicon goes mainstream. We'll come back to that. Let's go back to the second one in his list, which is simulated worlds will reinvent the way we experiment. We're going to be doing everything in the metaverse. Digital twins.
That's actually some of the subjects that I'm very interested in, and I do believe that that's going to be huge. No, I'm not talking about metaverse now, but digital twins. I think it can revolutionize a lot of things.
I agree with you, but I want to flip it on its head and apply it to what we do. We live in the digital world. I'm not talking metaverse either, right? We live digitally. Laptops, screens, or not laptops anymore. Can we believe we're going back to desktops and almost abandoning laptops? We live in the digital world. Can we have physical twins of our digital world?
Physical twins of our digital world.
Of our world? Why not?
Yeah.
Should we? Let's play this out here for just a second. I've been thinking about this for a while. This analogy is going to fall apart, though, so fair warning. We're used to doing everything in Kubernetes today.
Mm-hmm.
Ish. Even if you're not doing Kubernetes today, you're used to dealing with VMs.
Mm-hmm.
And you think about what's happening in VMs, right? It's electrons moving around on disk inside of silicon. Let's go back 20, 30, 40, 50 years. It was data moving around on spinning platters with heads moving around. I think we have lost. I'm not saying that we need to go back that far. But when you're modeling something and using something in physical space, you can find problems quickly. Like you can spot it, like going back to spinning platter disks. If all of a sudden you see heads aren't moving, you know there's something wrong with the disk. And knowing that helps you understand just because I'm using SSDs does not mean that my data is actually okay. Now, how you would physically model SSD, I don't know.
You know, the reason why virtual machines were successful and were successful at a specific moment in time is scale. What you said is perfectly valid, right? 1 server, 2 servers, 10 servers. Completely breaks apart when we're talking 100 servers, 1,000 servers, 10,000 servers, right? I think that all those two predictions, the one is about simulated worlds and so on and so forth, right? The reason why that is becoming very interesting now is because of the scale, right? And this is kind of partly biased because, hey, simulated worlds, I can already imagine somebody written from Amazon. It's about Amazon delivery and all that stuff, probably very much linked to the fifth prediction. But yeah, that's the scale we're talking about. The difference is that it's not one company being at that scale. Now there are more and more and more companies, right? Things we do today are much bigger than things we were doing when we were young, Darin.
That's true. I'm only halfway joking about physical twins. I think there's value in understanding the physical. But then does the physical become, as VR comes into play, is that the new physical? Could be, right? But let's stick with the digital twins for just a moment. Let's say that we're trying to model out something, like model out a city. All of a sudden we figure out, oh no, this water flow based on historical data is now going to cause a river to eventually pop up through the middle of the city. We probably shouldn't build those towers right on top of that fault, if you will. And then all of a sudden, we're playing SimCity again, right? That's exactly what we're doing here. It's just SimCity on steroids. But being able to go back and easily reset to 1 and start the simulation again from a certain point, that's not something we can do in the physical world easily, safely, or cheaply.
And even if you're not creating anything, right? Just from the perspective of statuses, all that is tremendously useful, right? Imagine that city that you know exactly which traffic lights are working, which are not, whether there is any movement, queues in a road, or whatever else you can imagine, right? Not having enough electricity here, water there. Those are all the problems that we've been facing a long time ago. It's just that now we can solve them better. One example that I'm slightly more familiar in practical terms is shipping. Partly because I was indirectly involved in a project of a shipping company building digital twins, right? And they were trying to do something similar. We want to know where each of our boats is, but that part is easy, right? All the containers, where they're located, how they're located, whether there is any movement happening, any piece of I'm talking about huge boats, right? Any piece of that, we want to know what's going on. And I want to know it in a way that one person can manage a fleet of those. Not replacing a captain yet, but many of the things, yeah.
It's interesting how you always take it back to a ship, which gets us to a container, which gets us to Kubernetes. That's fine.
This was unintentional this time.
That's what you say. But I think that's a great example, though, because I've got friends that work in the train industry, railroads, right? And it's been coming for years. There's maybe one or two people on a full train. You think about it, you'd have a huge crew potentially moving trains. And the things I found about trains is they have routes just like everybody else has routes. A bus route, plane routes, everything else. There's routes that trains will take.
And they cannot change it, unlike buses.
Right. And you have to wait. And if you're in Texas, you have to wait a long time to cross railroad tracks. Anyway, that's a different conversation. I wish I could model that one. But as these things can be, a train is one of those things. Tractor trailers now being autonomous potentially. If you can model all of these things moving out, let's stick with yours for a second because I want to see if it would even work. I've got my ships. Let's say how many ships do I have in my fleet?
100.
Am I working only the Atlantic or the Pacific?
You choose.
Let's do the Pacific because it's China to U.S. mainland. Yeah. Okay. What time of year is it?
January.
So no tsunamis, probably. So what route do I want to take? What is going to be the most efficient route? This little thing that we had called the pandemic, the ports are now opened back up. There's enough labor at the ports to help unload so I can quickly turn it. I'm not going to have to sit out at sea for 20 or 30 or months to get into port. We can do this in simulation. Dare I say easily. Because the variables there's thousands upon thousands of variables when you step back and look at it. But in reality, coarse variable or coarse high-level variables, I guess is what I want to say, there's probably, 50 to 200?
That depends how deep you go.
Pick up.
But yeah.
How deep, as I'm saying, is for coarse numbers, right? So, and I'm not saying coarse as it following north to south. I'm saying coarse like coarse ground type. If I know that, then I can start drilling from those points to where, okay, how can I shave off a few seconds here, a few seconds there? I think this will also apply, even though he doesn't go into the blog post, it goes back to his point one to where sports get tied in. Now, how can I do simulations to where, okay, if I adjust my gait when I'm running and I add an extra inch or I remove an inch from my stride as I'm running, am I actually going to cover ground faster or not?
Do you need, this is going to be said by a person who doesn't follow any sports, but these days or not long from now, do you need, what do you call it, arbiters in sports? Let's take a simple one. Let's take a very, very simple one. Running.
Mm-hmm.
I really need to know that somebody did not start before the given time and who crossed first and who crossed second. Realistically, a single person could devise that system.
I think it already exists today to where you get RFID badges when you run. RFID tags are buried in the panels that you put on your shirt, right? But it's those kinds of things. now I can model, okay, what happens if I put on 5 pounds versus what happens if I lose 5 pounds? What happens if I put 5 pounds on my legs versus 5 pounds in my torso? How is that going to adjust how I move? So simulated worlds, not just ships, trains, but maybe even humans.
For what I'm interested, kind of simulation, I think that's cool, but I see it more like entertainment stuff, all the metaverse and not. But from the business perspective, digital twins. I'm not sure whether, I guess that doesn't fall into the same category as simulation. I really know I have an exact replica of a real world something. And when I say replica, I don't mean, if I go back to shipping, that I have the hologram of a boat, but I know exactly everything I need to know about that boat at any given moment.
Because you've had sensors capturing in the boats for months or years, and now you have it modeled, air quote modeled, not hologram model, but you have all these data points that now you can actually figure out, okay, it took us 5-10 years to capture this information. We can see the patterns were reasonably linear. Let's model it. And I'm no data scientist, but that seems logical to me to say that. If I know if I've got normal headwinds or trade winds that will get me from A to B in 3 days, 20 hours, and 30 minutes, plus or minus an hour. And that has been consistent for however long because of these routes. Now I've got a good data set to where I can make choices.
And just start with simpler ones and then move forward. To me, a good example, without knowing the details, but I must guess that what I'm saying, there are digital twins behind it. Metro in Barcelona is almost, in majority of cases, if we exclude training or validations or testing, it's fully autonomous. There is no driver. And I must assume that there are digital twins of all those trains, of all those metro trains somewhere. Somebody's watching those things. I'm pretty sure of that, right?
Yeah, but I wouldn't consider that a digital twin. The digital twin to me would be, okay, how would I deal with, if this line is down from A to B, how do I reroute the train to minimize, how do I reroute the rest of the system in order to minimize the impact with that line being down? Like most of the time when you do, like in my town, we just have light rail. It's not real rail. But they'll send out notifications. It's like, okay, the line's going to be down all day Saturday until midday Sunday before track maintenance. Well, what if you had it to where you could plan your maintenance, which you should do, but you plan your maintenance and you chop up your system to where you never have to take the whole system offline?
And that's an easy case, right? It's planned still in somehow. But now, if you go a bit further and say, random things can happen, and it does. And I want to intelligently manage the reactions of all those random things happening.
We're injecting chaos into that system.
Yeah. And I'm not now talking about artificial intelligence or none of those things, right? The first step is that I need to know exactly at any given moment where everything is, and with which speed it is moving and how it's behaving and things like that, right? I need to have a digital version of every second of the world. And when I say world, I mean within the constraints of what we're talking about, right? And that's still me manually resolving problems, right? Kind of first step, I know the situation of everything. And then how can we do it more and more efficiently until one day we get to the point where actually the system is auto-correcting itself. The real physical system.
And noticing your process as you went through there, the auto-correction is the last thing.
Yeah.
Not in the middle and not at the front.
I mean, I cannot teach a computer, artificial intelligence, how to do something if I don't know how to do it. That would be kind of ridiculous. Now, eventually, you're a teacher, I'm a student, you need to know your stuff before you start teaching me. Eventually, I might outgrow you. That's absolutely possible and often happens. But until then, you need to know what you're doing, right?
So let's go down to the fifth prediction. Custom silicon goes mainstream. And I want to read the sort of summary on this. Usage of purpose-built chips will rapidly increase in 2023. M1, M2s, anyone? As a result, the pace of innovation will accelerate as workloads take advantage of hardware optimizations that maximize performance while, going back to the energy one earlier, while lowering energy consumption and reducing cost. Now, there's a couple of statistics here. At the time of writing, which this was beginning of December of 2022, 100 million EC2 instances are started every day. 100 million. That's mind-boggling to me. I haven't even done the math on that. There's 86,400 seconds in a day. Okay, here. I'm going to type loudly so you can hear me typing. Divided by 86,400. That means there are roughly 1,157 EC2 instances started every second. AWS knows scale.
Oh, yeah.
All right. But that's not the big point. So let's get that's just like a mind-boggling number. But let's look at what they were trying to go here from the silicon perspective. So there's a 50% cost of training savings if you use a Trainium-based instance, which is one of the things, instead of using a normal-based instance. And then 60% Graviton, which is their ARM-based processor, costs significantly less and use up 60% less energy than comparable EC2 instances. I'm assuming that's their dig at the Intel-based instances. OpenAI has been creating more and more buzz as AI. Okay, I hate the term AI. Let's say it this way. Learning models. As we start to have more and more learning models, the general purpose CPUs are going to not be as useful. Heck, even the GPUs aren't going to be as useful. Processors that are created for specific use cases, which is what a GPU was, right? It was created for graphics. But we've gone well beyond graphics now.
Created for graphics used by miners.
Miners meaning Bitcoin miners, just in case, for context. But yes. Because it's math, right? It was for math. Think about the life change that we have had, you and me, by moving to Apple Silicon on our Macs, as compared to the Intel-based Macs, which are still very good, by the way. The more, heck, I still have a 2015 MacBook Pro, and it's fine. It's not great compared to my 32 gig Mac Studio, but it does everything I need. Plus, it gives me tooling that I need for certain Intel use cases that the M1 isn't there for yet. But the M1 was never meant to be a general purpose.
And Intel is just
CPU, in my opinion.
Especially good in winter, man. It provides free heating.
Free heat, yes. What do you think about custom silicon just becoming normal? That now instead of just seeing normal CPUs, GPUs, we're now going to start seeing breakouts of silicon created for specific use cases.
Yeah, that must be happening, right? And it wasn't happening until recently. That you had Intel, AMD, more or less same processors go everywhere. Pick one of the two, and that's about it, right? But no, we're not talking about vast majority of CPU going into computers or traditional computers, and I include EC2 instances over there, right? But everywhere, fridges, cars, cameras, doorbells, everything needs a CPU, right? And the whole idea that we had until not long ago, where you would say, hey, My job is to design a CPU, and that CPU will work everywhere. Does not cut it anymore, right? Simply because before we had a limited number of use cases for CPU, mostly computers. Now it's getting close to being everywhere. If you go back to the previous conversation about digital twins and simulated this or that, right? We're talking about sensors. Sensors are not going to have gravitons or whatever was mentioned by AWS, right? Most likely, hopefully. So we're going to be seeing probably drastic increase in jobs for designing CPU, right? Instead of just buying, hey, what's the latest of Intel?
I want to read a sentence or two from the last paragraph in this point. Alan Kay once said, "People who are really serious about software should make their own hardware." Apple, anyone?
I'm not serious enough yet, though.
And to finish this up, and in the coming year, people who are really serious about software will really begin to take advantage of all that custom silicon has to offer. You were saying jobs for creating CPUs. I think it's a hair more generalized than that. It's the jobs creating the silicon to do whatever it is, because it may not be a CPU.
Yeah.
I mean, technically it's a CPU, just like a GPU is a CPU.
Yeah.
I would love to talk to people that are creating custom silicon. If you're listening to this and you know somebody that can actually talk about custom silicon without giving away all the gory details, I'm not saying at Apple or anything else, but anybody that can talk, that would be a very interesting conversation to have. Because we take for granted, Victor and I take for granted every little processor we have running. All the way from my little multi-year-old Raspberry Pi that I still run a Jenkins server on because it just works, all the way up to my Mac Studio. Right, those are in my house. I'd love to find out where people are trying to head, if they can talk about it. And we'd like for you to hear about it too. So Victor, what do you think? Out of these 5, what was your favorite one?
Oh, the second one, the one about the simulated worlds, digital twins, things like that. I'm still mostly on a bytes side of the story, much more than hardware. So yeah, simulated worlds. Please let the future not be Facebook. I'm going to get depressed.
Yes, just not the metaverse. And nothing against the metaverse, but that's just not what we want to have.
Cannot be owned by Facebook.
I prefer it just can't be owned by Meta, but
Yeah.
yes, cannot be owned by Meta. My favorite is actually the silicon, because I think that's what's going to make the digital twins extremely possible
Yeah.
and usable over the next decades. What do you think? Go ahead and head over to the Slack workspace, look for the episode 205, and you can leave your comments there. We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.